Johan Adami is a software engineer at Stripe. Now, Stripe has broadly adopted Apache Pinot for a number of real-time analytics use cases. His colleague Lakshmi Rao has been on the show recently talking about that. Johan today is talking about his work trying to build out Pinot as a service internally for Stripe. We talk about what he's learned about building a service and about Pinot itself on today's episode of the Real-Time Analytics Podcast. Let's listen in. Hello and welcome to another episode of the Real-Time Analytics Podcast. I'm your host, Tim Berglund, and I'm joined in the studio today by Johan Adami. Johan is a software engineer on the stream analytics team at Stripe. Johan, welcome to the show.
Hey, Tim. Thanks for having me.
You bet. Now, you spoke at the Real-Time Analytics Summit 2022, the online version. So, and that link is going to be in the show notes, but maybe people haven't seen it yet. What was that talk all about?
Yeah, it was, I would say, our second foray into Pinot. So the first one was a more lookups use case with financial data. So it was pretty cool. That was the really large multi-petabyte table that has been presented a few times. But the talk I gave was moving our existing Hummingbird time series system onto Pinot. So this one, man, it was quite a talk. There's a lot going on there. It was it was a long endeavor, but effectively this is the high strict SLC use case. So we're looking at P99 query latencies of less than 75 milliseconds. We're looking at ingestion lag less than 30 seconds, and about 20,000 queries per second is, I think, where we're at now.
And is that on petabyte data?
That one, it's, I would say, terabyte data in aggregate.
Okay.
But
okay.
These I would define more as, and I mentioned in the talk, they're more streaming jobs. So a user has a data source. They're typically defining some sort of filter for the data, an aggregate, and then they define some key that they're going to query by. And when they do the lookup, we're effectively already aggregating in real time. We're pre-aggregating the offline data. So this is the hyper-optimized use case. We are trying to minimize the lookup as much as possible. And what that means is you get really good performance, but if you ever want to answer another question with that same data, you are doing the same thing again.
Right. That makes sense. What you're doing now is kind of next level. You're sort of moving into Pinot as infrastructure or Pinot as a service inside of Stripe, and some kind of cool stuff going on. Tell me what that's like. I mean, that's a whole conversation right there.
Yes, it's a whole conversation. It's also a whole team. There's a lot there. So, I mean, with the initial success, we kind of saw Pinot was more reliable than the previous system, and folks started approaching us internally about both internal and external use cases. So beyond the folks that just picked up Pinot anyway, regardless of like how ready we were to support the use case, they trusted it enough to get started. Other folks showed up that were maybe a little further down the stack. Like, I have a data source, I'd like to be able to query it in real time or with really low latency. How do I get started? And it turns out that's a little harder than you think. So usually I feel like when you have a database, as a software engineer, you're starting out, you pick your favorite like web framework, you start out and you add a database and suddenly it's magic.
That's the good old days. Yeah.
Right. I have a real thing.
Yeah.
And then all it needs to do is break once, and then you become terrified of databases, and you really want an expert in that space. But I would say Pinot has a lot of that too, where getting started is really easy. Like the documentation's great. The code itself is pretty approachable. You can start ingesting and querying data easily within a day. But when you want to do it with bigger data at scale, you want that very high reliability. Just start thinking a lot about how you're going to architect that. And yeah, go ahead.
Yeah. How many software engineers are there at Stripe? Do you know roughly? So you're, trying to make this available as a service. How many people are you talking about that are going to be clients of that service?
I'm actually not sure how many people would use it till
Yeah.
it actually gets more popularity. I mean, we'll start out with we've started out with a handful. I would say it's grown to dozens plus.
Okay.
But
That's a lot. I mean,
yeah,
you're not going to directly know and deeply trust dozens of people. Like, you can know their names, but you're not going to know them well. And, that's the difference between a team standing up a piece of data infrastructure for their own use. Like, everybody kind of knows the rules and trusts everybody. And now you're making that available as a service inside the company to kind of people you don't know who are doing different things and, maybe not thinking about your concerns all the time. So you just got a lot to do to make that work. So what, yeah, like, I guess, tell us what you're building out and what have the challenges been.
yeah, you make a really good point. I think working at I've worked up and down the data stack at an oncology health tech company, and when it was a lot smaller, it was a lot easier to be in every role. Like, I was potentially in a data science role for a while where I was working on the actual data set with clinical specialists, and all the way to working on the data pipelines themselves, like the infrastructure for how other developers ran it. At Stripe, we're pretty squarely focused on Pinot on the team, and it's really up to us to ensure that for the right use cases, we make sure to embed ourselves in the team to understand it, and then for other use cases to make sure that we're just building out the platform so they can onboard more easily onto Pinot. But in terms of what we're building out, I go back to the Pinot table configuration, which is both.
Don't we all?
It's both a wonderfully well defined thing, and it makes the whole thing very challenging. So you as a user have an event or offline data, and you want to ingest it into Pinot. You define this schema and table configuration. So for listeners that may not know, the schema is what you'd expect. You have column names and types, but the table configuration is where it gets a little more challenging. So this is where you define your indices, which are what make Pinot queries fast. But for a highly available environment, you also think about how you want the physical data to be stored on machines. So you will define tenants or replica groups, which are effectively isolated servers serving that table. You have to pick how many replicas you want and how many servers you want per replica. And I think one of the challenges we had with folks who initially wanted to onboard onto Pinot is they say, where do I get started? And the answer is, here's this series of 7 steps. Begin with set up Zookeeper and the rest of your servers. And then you can follow the rest of the steps to get your data into Pinot.
Now, and for the uninitiated, if you're listening to this podcast, you don't know Pinot well. Yeah. So in a traditional SQL database, you've got a create table statement, and then you might have a series of create index statements or something. You've got some DDL that is going to define the schema. So in Pinot, there's the one's JSON file that's just a schema. And then there's this other little bit more complex JSON file that's everything else. It's indexes. It's, like you said, it's replication, tenancy. If it's a table that's ingesting from Kafka, it's literally got the Bootstrap server address there. It's like everything is there. And it's the hub of a lot of your work.
I would say to make Pinot a service, I think we quickly realized that we want to get folks back to being able to look at the open source documentation as quickly as possible in a way. And rather than treating the creation of a table as just that one API call that you might be making to the Pinot controller to create the table, really think about it more like a workflow. So what that means is, I have a data source, but we allow you to specify how many instances do you need, what would you like to call your tenant, or would you like to reuse an existing one? And once you actually run, we'll say some command to create the table, we will actually provision that infrastructure for you. And the beauty of that is it's pretty opaque to the user. Maybe it's not as instantaneous as it could be, and that's something that can always be improved. But it really addresses that initial pain point of, I want to get started with Pinot. I really don't want to have to spin up an auto-scaling group or multiple auto-scaling groups to start.
Right. Are you in the service that you're creating? Do folks who want to use the service do they still provide their own table config? I mean, what level of abstraction are you creating? What's the interface that they see?
Yeah, we've tried to put a lot of thought into this, and there's always, I felt like there's always more room for abstraction. It's a lot harder to remove abstractions after the fact. So we effectively, especially for the table configuration, we chose to just stick with the open source stuff. Like whatever you would see in the documentation, you can do that internally as well. And that, I would say, gives us a lot of room to further abstract, but to continue working on the platform without having to stop and consistently answer or educate folks on questions about what does the table configuration do, because the answer is in the documentation already. But obviously there's a lot of, once the rest of your data platform provides clear APIs for things like, what does the schema for this source look like? Where is the actual data in the cloud for this so I can load it into my servers? Like once those APIs are clearly available, it's not infeasible that it's just a one-click thing.
There you go. Nice. You mentioned replica groups and you mentioned tenancy. Could you, for the uninitiated, talk about how those things work in Pinot, what those things are? I don't know that we've covered them on the show ever. So here you are, you're first.
Yeah, that's fair. There's many pages of documentation on these, and I've become intimately familiar with them and the code, just trying to understand, why it works the way it does. It's a really interesting piece of technology. But in the end, Pinot is a columnar data source or data store. And at some point, the data has to physically make it to the server to answer your query. And usually you want your query to be as fast as possible, which means querying the least amount of data. And you want your query to be highly available, which means you have replication set up. So Pinot offers knobs to effectively isolate your table from other tables. Those are the tenants. And it offers knobs to replicate your data across basically groups of isolated servers. Those will be the replica groups within that tenant. And from there, you can actually control the actual segment or data assignment on the servers. So you can choose which partitions end up on what servers for even finer control. And we do some of that, but I think we found that using replica groups has probably been the best performance for the complexity that it requires to support.
And the basic idea of the replica group is to make sure that in that group, all of the segments of a particular table are going to be present.
Exactly.
Is that right? Am I getting that right? Yeah. Okay.
Yeah. Ideally, if you ever lose any part of the replica group or the whole replica group, it's okay, because the remaining replica groups have all of the copies of the data for the table. And Pinot's default setup is actually a balanced strategy where the segments are assigned in a balanced fashion across all the servers for that table.
Yeah. So the server with the fewest segments wins the next segment.
Yes. And what's funny is, we've seen cases where that actually provides better performance. It's a real tricky game of how many servers do you parallelize your query to versus how much work is each server individually doing.
It is because on the one hand, you'd like to do lots of parallelizing. There's always a transaction cost to parallelizing, but that should be relatively fixed. And so, more servers is better because you'll split the work up into more pieces and get them on parallel. But then there's a reliability problem. Like if one of them breaks, And tail latency, right, is the other thing people talk about there, because you've just got more servers where one of them might have a little garbage collection event or just be having a bad day. And so it's just not clear which one. Do you do lots, or do you do a few? And so,
Yeah. So for the talk I gave last year, I would say it was almost a blessing that all of the queries looked the same, or they needed the same performance, which was sub 100 millisecond. So you can be pretty strict on how you do this kind of replica group setup, how you assign segments and so on. But for newer use cases, folks want queries that will maybe take a couple seconds or 30 seconds. And it's a different kind of challenge. We've already found that, if the query is going to take 30 seconds, you probably don't want to constrict it to fewer servers, because the network cost of going to a server is really not that high relative to the remaining 30 seconds for a query. Like spreading it out more gets you better parallelism.
What kind of queries are those, out of curiosity, that if you can talk about that?
Usually, so last year, all the data was pre-aggregated. This will just be queries on raw data, and it will be terabytes of raw data. So depending on what you're querying for, you could be looking at tens of millions to billions of rows.
Okay. And aggregating scanning and aggregating over all of those, not some small set.
Exactly. And really what I found is when I see a query that takes 30 seconds at this point, I assume it can be optimized further.
Yeah.
But the interesting thing is, for some folks, it almost doesn't matter at the start. That 30 seconds is likely already better than what they may have gotten through another system. So they're actually already happy there. So
gotcha. And those are non-user facing kinds of features. That's not a feature in an app. That's
And that's where I have to stop myself a lot. Even for user facing things, something will take up to a second, and I really want to look at it, and I'm like, I bet I can make this a little bit faster. But the thing about building a platform is you really have to pick and choose where you personally deep dive into the product versus where you focus your time on the platform instead, and try to enable even more use cases.
Right. Yeah, fair point. You don't want to optimize things that people aren't asking you to optimize. And 1 second for a user-facing query isn't impossible, right? That's a long time, but it depends on what the expectations are and how many other queries are happening and just what's going on in the app. I can see that being fine. If there are 15 of them happening every time somebody taps on something, that's not going to work. That's when you get into your crazy 20 millisecond type of life. But yeah, no, that makes sense to me.
Yeah.
Okay, so keep going. There's basic problems of defining replication and tenancy, and you really are in your service exposing people to the whole of the table config. What are some other challenges that you've bumped into? Like I'm just going to guess. You're exposing a database service. I've heard from DBAs that I've been friends with that sometimes people submit queries that are expensive or run slowly. You were just talking about 30 seconds, but do you have problems with queries that break things? Like what's that look like?
Yeah. So this is where I would say the isolation is really good. And I think we're starting out with, you pick your level of isolation that you want. So as a user, you can kind of decide that, which doesn't mean that you won't break something, but it should hopefully limit the case where one back query is catastrophic to the system. I somewhat am relying on the open source community to address some of this. I know there's already work in terms of being able to limit queries based on the resources that they're consuming. We enforce table quotas, but on top of that, there'll be CPU and memory quotas, is my understanding.
Okay.
And I think we like to pick up new features and try them fairly quickly, especially when there's new use cases coming on. So it's a really good chance to effectively give us the ability to test a new feature with a new use case that may or may not need it. but so far, I think we have a handle on what folks are running. Uh, and that's been, it hasn't, it's thankfully not been too challenging to make sure that no one's taking things out. But I know Uber, for example, has given a great presentation on how they do this with fingerprinting queries. Yeah, there's a lot of good strategies there, and I think we'll definitely tackle it as it gets closer to a larger scale internally.
When you so this next question, stop me if at any point I'm like asking about things that feel like secret sauce, but I'm just sort of out of curiosity thinking. So you provision a new user. There's probably a Kafka topic that's got things that they want to ingest most of the time, or maybe there's a pile of batch data. So like they're setting up a new table, and is that typically the thing? Like, okay, I've got a new table. So with that, do you now provision new servers and set up tenancy so that table is allocated to those new servers, or do you have like one big cluster where there's I know this relates to the question we just talked about boundarying bad queries, but how far do you take that? Is it always a new isolated tenant for a new table?
It's not always. So
okay.
we leave that part up to the user. One thing about offering Pinot in this way is we are starting with one cluster, but the idea is always in our mind that it will and should be multiple clusters where the user's only aware of the table. So we can manage eventually where the table lands. We can route the queries to the correct place. And we're not quite there yet, but that is, at our scale, I would say, something that's very important to be able to do in the future. Like that is a trapdoor decision we don't want to make. But something you said that's interesting around like the table creation, I know we've talked a lot about it. That is almost now, once you've got some of this orchestration set up, the easier part. What gets harder is folks would like to iterate on their table.
No, well, they have to get all that right at first. And yeah. So, okay, talk about changing tables.
Yeah. So I will say for as awesome as the Pinot documentation is, because there's so many configurations, there's actually not much in terms of how to change a table. There's a pretty good document on schema evolution, adding columns. But when you change your table indices, when you change your replication, if you want to change tenants, the way you apply those changes is always kind of different. You change the replication, you need to rebalance a table, which is an API call. If you change the indices, you need to reload the previous segments, which is an API call. But the new segments will always get the new index. And this is highly technical, mostly to illustrate that it's not one thing. It's not just one way to do anything. You have to plan for this, and you have to make it available to users.
Yes. So we're recording this middle of September 2023. Current state of the documentation, not always clear when you're changing something in like what do you have to do to make that take effect. And you just went through a list of a few different things. And it's funny because just this week, the documentation team at StarTree is a part of the DevRel team. And we focus a lot on StarTree documentation, but we're also contributors to the Apache Pinot documentation. Spent a lot of time on the Pinot docs, and we were just talking this week about how it's not quite clear yet in the docs what you have to do to make various kinds of table evolution take effect. So with you on that, we're working on it.
Yeah. And again, all of this, I mean, it's a complicated system. So I would say the documentation is wonderful as is, and always that. Room for improvement.
Always.
But mostly I wanted to illustrate this challenge. Like, you making a table now is not just that one API call. It's the ability to provision the infrastructure to make the initial API call, and then to make this determination if what change the user is requesting is destructive or not. like a very surprising one I found was when you add a column, it's pretty clear in the documentation that adding a column requires reloading the previous segments to fill in effectively the value for that column.
Mm-hmm.
And it sounds like a backwards compatible change, but what I realized is if you are running a select star query for some reason, and usually that may be exploration, but if you happen to be running a select star query, it will then fail because it will try to query the new data on the new segments and the missing data on the old segments.
Until you do the reload.
Until you do the reload, which, and these are the kind of things that when you're trying to provide Pinot as a platform to folks, like you do need to be aware of. And maybe, if you're lucky, you'll only run into it when someone's first getting set up and the use case isn't live to users. But,
right.
You ideally want to get this all figured out before it happens in the live system.
Yes, indeed. Where are you taking the platform in the future? What does it not do that you wish it did?
Oh, man. I've had the talk only gets more technical. I've had a lot of ideas, and some of them I would say are well tied into things we've heard folks want to do, and some of them are just in a vacuum I think are cool. So one that I thought about deeply since the initial talk I gave was about the way segments are stored on servers and kind of in a current invariant in Pinot, I'll say. One of the nice things about our previous aggregation system was it would store data batched by time, and it kind of abstracted away the time with this idea of a batch ID. But what it did was you could pick your time buckets, meaning you could bucket the data by year, month, day, hour. And when you sent a query for a time range, it would effectively pick the ideal number of buckets, the minimum number of buckets effectively to look up and provide you your answer. And I thought about that, and the system was a Lambda system, so there was a real-time and an offline portion. But that batching made me realize that there was basically another layer on top of that, where there was another decision to be made about how you pick the physical data to answer your query. And that's something Pinot only slightly offers today. So you have your real-time table and you have your offline table, but it's expected that the segments in the table all run on a single timeline, we'll say. Like the end of one segment in terms of time is the beginning of the next one.
Yes.
And you can, for example, add a StarTree index. That's kind of like what I would say is maybe the one layer inside the Lambda system where you could short circuit whether you query that data or not, because you might already have the answer. But you can't do things like store two versions of the same segment for the same time range with slightly different indices. Or maybe you have one really large segment for 1 year of data that's pre-aggregated, and then a bunch of smaller ones for queries that actually require that granularity in there. And the reason I think about this is the previous system is, like I said, was all streaming jobs. You define a question you want to answer, you answer it, and that's the one answer you get. Pinot moves you more towards, I have a data source, I want to be able to query it. But I think what naturally ends up happening is folks say, I have this data source, and I know this one query I'm going to run every single time. And I would like it to be now hyper optimized. And that may not necessarily play well with the next person that wants to query that same data source. If you are, for example, forced to pre-aggregate your data to get the best performance, the next person might not be able to rely on that.
Right.
But if you could store the pre-aggregated data with the raw data, that's now you kind of get a little closer to, I will always have one Pinot table for a data source. Whereas I think today, depending on the performance people are expecting for their queries, we actually have replicated the same data source into multiple tables
Okay.
pre-aggregated, indexed in different ways, to be able to answer different queries with really low latency. Yeah.
And building that into the platform, that becomes a platform feature for you at some point. The different views of the same data, they're copies of the same data, but you want to kind of build that in some way.
Yeah, and you know what? I guess you asked about the platform. This would be squarely like a Pinot thing if we were to ever need to prioritize it. And this is kind of what I meant by there are things that we will likely need in the future, and there are things that I've thought about would be really useful in a system like this based on other technologies that I've worked with now. For the current platform, I think I would only want to simplify what we've done today, which is, I mentioned, I think we talked before about Kafka and scaling up. You can add a Kafka broker and be pretty confident that the new partitions or current partitions can easily move to that one. But adding a new Pinot server is a bit of a challenge. You provision the infrastructure, but then you have to make an API call to tag it with the tenant you want. And then you have to make another API call to rebalance the table. And you have to be pretty thoughtful about executing those steps in the correct sequence and in a good workflow. Even though Pinot does have the ability for servers to auto-join a cluster, it's one of those things, like I said, where it looks like it would be easy, but when you actually want to run it in a isolated way, it's quite a bit more challenging.
My guest today has been Johan Adami. Johan, thanks for being a part of the RealTime Analytics podcast.
Hey, thanks for having me.
And there you have it. If you feel compelled to help us spread the word and grow the RealTime Analytics community, you can give us a rating on Spotify or Apple Podcasts or wherever fine podcasts are sold. If you're watching us on YouTube, hey, subscribe and, of course, hit that notification bell. And you can always share your favorite episodes on LinkedIn or Twitter or wherever it is you do social media. Thanks, and I look forward to talking to you in the next episode.